chapter, which is on the process concept. Still, you are in the phase of theory term, but still understanding also some of the part you need to use it in the understanding part term. So you will going to learn on definition, process stage, process control block, PCB, and another one is process creations and termination. This is on your operating system, your OS, for your computer. Normally you are just playing around, you have a monitor, you have the CPU, you have your mouse, you have your headphone, earphone, and then your keyboard, your microphone, and etc. So basically you don't know deeper on what is function inside. I don't know, maybe you are expert in computing, but you need to learn on it. This is the architectures on block diagram for your PC, but it is mainly for your hardware. So you have over here on your monitor, if you can see over here, you have a monitor over here, and then you can also have a keyboard, and you can have your mouse also, and all others here. It is just the another different of devices which is not inside your CPU. This is your CPU, which is in this block of this blue color, and on your CPU, as I already mentioned before also, if you remember, you're going to have your memory, you're going to have your CPU itself, you're going to have the RAM, ROM, and then storage part, isn't it? And like your monitor is going to be your output device, like your mouse, it will be your input device, etc. So over here, if you can see let we go to the easiest part, which is on your monitor. It will link directly, so there is a several way how you're going to link your monitor to your CPU, isn't it? If you did not link your CPU to your monitor, then you cannot see any output, isn't it? So there is a on your graphic solution also, there will be a selections on that, depending also on what type of monitor that you are using, isn't it? Agree, right? So on your keyboard also, you did not have the existing CPU, which is already built in the keyboard. All of this is the input device that is not directly built in the CPU, so you need to have some interface to connect them together. So the connections will be using this interface, which is local bus to EISA bus bridge. This interface will connect also and will handle also on the connections of your mouse, on your connection of your hard disk, which is on your main storage, operating system, and application, and then another one is on your floppy disk or any type of storage media, which is input and output device. And of course, on your CPU itself, you have not the actually existing built-in device. If you check on your CPU, sometimes you only have one interface internet network card, but there is empty slot. If you check on your CPU, isn't it, there is empty slot. So that empty slot also you can be installed with any type of, let's say, a card, maybe a graphic card, maybe the internet card. So it's depend on you, but you need to know that for certain slot, it will be having the interface. Let's say like this over here, on the port or on the slot for you to connect and to install with the internet network card, say a modem, or maybe a printer board. So this interface, which is called as LAN network bus, will take over. So inside your CPU there is a LAN network bus and it will connect it to your interface, but basically it will be inside over here also, right? It's not outside. So you can basically have the port or the slot inside your CPU, then you will link it to outside, like printer, like a modem port, like even your network card for your internet, also you are installing it in on top of your CPU. So next you can have the bus, like your CD-ROM, your external floppy disk, your scanner and each. So this part will be handled on your local bus to SCCI bus bridge. So it's depend on you what type of disk, which is storage disk, whether it is floppy disk, it will handled by EISA, but for the CD-ROM it will be handled for SCSI bus. Later on you will learn on what is this basically. So this is just an overview for you to understand what is inside and what is the diagram for you to connect all everything inside the CPU. And then you're going to have your CPU, RAM, of course, ROM, and then memory and etc. You have the power on button set, and then you're going to connect to the interface boot, BIOS boot, which is memory firmware. Sometimes when your PC is already occupied too many in storage, then you have only left over like maybe 100 megabyte, or maybe let's say I make it 1000 megabyte. Let's say I just give you example, isn't it? Okay, let's say you have your space 1000 megabyte, and you said, or you still have a space similar to also to your phone. You check that you still have the small portion for empty space, but there is a situation when you try to open your PC, your computer, PC and computer similar, your laptop, your mobile phone, then you cannot open. Then it mention you that you didn't have enough space just to restart or to turn on your power of your device. This is because you already occupied this space for your memory firmware also. Although you have another 1000 megabyte, but it is not enough for you to handle this for ROM, which is, it is depend on your system actually, right? Depend on your CPU or your phone or your laptop. So that's happened, although sometimes your phone is okay, nothing corrupt, but you have low in space. Also sometimes you cannot open your laptop or PC, or also in the phone scenario. So this is the important part for you to know. Whenever you want to open, then you cannot because of the low space disk. Okay, on definition, so it is just a term you can read by your own, but let me go through with you one by one. So a process is just a simple anything that you're doing in the CPU or in your processor. It's called as a process. Wherever you have the input that been given from your input device into your CPU, then you will process it. It's called a process. And and after you process, then you will be getting the output. So I think last time I already showed you the flow, what happened, what is the device for your input, what is the device for your output, and also in terms of your CPU, inside there is a memory, there is storage part, storage also, there is a main storage and secondary storage. Similar also in CPU, RAM, ROM, you need to know all of that. And then it is an active entity because it should be an active because it's still a process. And then two processes may come from the same program, yes, however their executions are different. So you can and might have two processes in one program. It depends on what application that you are open. So there we will given the example over here. If you have two users are running a Word's Microsoft, let's say Microsoft Word, it's very simple example, and then two processes will be created, isn't it? Because you have two users that running a one single word processor. And then a program is passive entity whereby it is comprised of program coding, which is a static entity. Therefore a program itself is not a process. So there is a two term on here. If let's say you know about process, it is active entity, and a program is a passive entity. So this is on just a definition. Of course there will be question asking in this term about definition, so you need to remember process is active and then program is passive, vice versa. As long as you can understand the situation which is program. What is the program? Program is the application itself that are running the process. So yeah, some sort like that. And then on the components of process, you need to know that they are totals of the components of your process 3, and this part I will show you later. And it is include the program code, context of program executions, and another one is program data. So it's just a simple component in the process that you need to remember. What is a program code, which is the one that you doing the coding and etc. over here. Then you can get the application or the program itself. Then on the context of program execution, you have the context on your CPU register. So another information is you need to know is on your operating system, just as a process state, scheduling information, and etc. I think you can just go through and read it. Here in on the operating system, I think this one should be on top. Last time I already show you this diagram, isn't it? But in terms of different presentation. So in this one you can see that you have I think basically input 1, and then you have the output is 2 device, and then you have CPU, and then you have the storage and memory. So all together you need to know that you have 5 elements. Is a 5 element? Yes, 5 elements that you need to know in using your PC or laptop, the process of computing. So what is the first is the elements of your input device. What is the example of input device? I give you the example of input device is your keyboard. I think this one I already discussed with you, but I just want to revise as long as you can remember. So the one that was who already expert, just ignore it. So input device, it can be your keyboard, and then your microphone, and your camera webcam, your not printer. Printer is the output, but scanner is the input device. So sometimes you will feel confused. If printer not similar to not similar to scanner. Yes, it's not similar. Scanner is you scan something, the document or the image, then you tag and grab those after you scan to be in your computer to process. So it will be sent as input. But for your printer, you are from your computer, you were given the document and you want to make it up, process and make it out to be printed. So that's why printer as the output device. And output device also include your monitor, include your speaker, your headphone or earphone, also your output device. And you have the CPU, the third element. Fourth element is memory, and another one, the fifth element, is storage. So storage also, you need to know that there is a several storage, which is primary storage and then secondary storage, same to your memory. You have the main memory and secondary memory, but on top of this, you just begin shows only the basic one. But I just sharing with you that you need to know about that. On your CPU, you will be having two functions, which is control unit and also LLU program in your CPU. Arithmetic logic is it functions unit, sorry, logic unit. So ALU and control unit is the heart of your CPU. If you don't have these two, then your CPU cannot be turning on or maybe corrupt. So next is on your process state. All of this note I will provide it on your e-learning. Okay, you can just go through it and do a revision back on that. So process state, this is one is on the process. You already know that process is active, but they will be adding on state. That's why process state will be saying that active, which is activity, but it is a current activity of the process. When the process is executed, then you will know that process will be changed from one state to another, right? So let's say it will convert the image to the text, and then after that the text will convert to so step by step. It's not directly in and out, something like that. So changes state after an event occur. So after this state, what happened? After this state, what happened, etc. So a state transitions diagram can tell what event causes for a process to change the state. So whatever, let's say, after you need to know, let's say I give you the example on you type something in your keyboard, let's say H. So then after that you type HELLO, hello. So what is going to be in your PC is it will be converted it into the computer language 1010, right? So after that, what will happen? So next step is you will having the state transition diagram. So what will be causes? Let's say after you reach the CPU will first change to the computer the program, which is they can read the language of your computer language, which is 1010. So if let's say after you finish converted it, then it will be doing any process, next process. So after certain process finish, then after that you can change to the next stage. So there is a process stage which is 2-stage model or 5-stage model. And then process with 2-stage model, so you have a process can be in one which is following state, which is running and not running. So state diagram is like this, which is whenever we enter, let's say it's not run, so you have the possibility on displace it or just pause. After you displace, you can also run it and then you exit. It depends on how state that you will pick, whether you're going to dispatch or you're going to pause, and then you will be run and exit. So this one is only 2-step model. This is on your 2-step model. So you have only 2 steps, which is not run and also run. But there is another state which is I already show you here in the diagram. You have 2 state only for the process state model, 2-state model and 5-state model. So for 5-state model, you have new process, and then running, after that is ready, and then waiting or block, depend on how you execute this ready, and then you exit. So you can see that new is the process is just being created, and then instruction are being execute when you execute the new created process. After that you will be ready and wait block and exit until end. So different operating system has its different names of state. This is in terms of diagram. So you can see that you have new, ready, run, whether it's waiting or block, and you will be on the exit. So you have 5 states. So for the new, and then you will admit it to be ready. So this is just a normal progress and process. And after that, you just having to dispatch it, not like 2-state, which is you can have the pause or the space for the first this one, but after you're ready, you just directly dispatch. And for the running part, it will wait or it will be interrupt to be back to the previous state. So maybe it's be interrupted, you stop or you renew it back, and etc. It will be back to the previous state, or it will be even wait. But if some cases after you dispatch and running, the program is just directly terminate it to exit. But if let's say you have the event wait, you will be waiting until the event occur, or you trigger your program with something else to start running, then it will run. So process control block PCB. So each process has a PCB. Every process, whatever you are doing with your computer, in behind you don't know that basically it created the PCB, which is called as process control block. And then each process PCB store information related to the process. Whatever information about your process currently happens, it will be Why my series turning on? Suddenly it's already 4 o'clock. Okay, then contents of PCB. What is inside? You have one which is for process identification, and then you have process state information, and another one is process control information. Then you will be look into all of the process. So you have what again? On the context of the PCB, you have three, which is progress identification first. So over here I will just briefly share on you whatever in the slide. You can just read it because it is just a theory part. So on process identification, it is on the numeric identification that may be stored with the process control block include, which is identification of the process, and then the process that created this progress, which is parent progress, and then another one is user identifier. So this is on process identification. So it's quite easy for you to remember because this is just on the identify part only. And the next is on your process state information. What process is inside is general purpose registers. So you have the general purpose register. You also normally it will be using happen whenever you are dealing with a control status register like a program counter, program status word, PS word, PSW, condition on your codes, execution mode, stack pointer, and many other more, which is on your progress state information. And lastly, on the third one is on progress control information. So whatever you do on your control information, then you are under this process state, which is schedule information such as the priority, amount of time execution for last time, and on your memory like pointer to page table and etc. So you might read what is the examples of each process that available, only three. And then on the operation on process, so generally OS need to provide a mechanism. Of course you need to have a mechanism for your platform. It's needed for you to process the creation. So whenever you want to open a new program, which is you create a new process inside your PC, which is you create it. Whenever you open, let's say your window, and you run another application, whatever application, then you create a program for your window or your PC to run, isn't it? So it will be a process on creation. A process can create another process also. Let's say I have what is process that open two time. Let's say I give you example. This is just example, okay? Whenever you open your website, let's say in your PC, sometimes it will open your website and also another link which is directly linked to be open in the website. Let's say also like this, maybe you are opening your email, your Google Chrome, and then it will suddenly open also your existing application by default. So it's depend on you. You can set it by yourself. Similar also, let's say you open your PC, then by default you run it to open another application like your screensaver. Maybe you directly open your antiviruses. So you just creating one process, which is, let's say you open your PC. This is one process example. Then after that, it will directly open another process or another program. It's not a program, process, which is opened new program. So it's called as a process of creation. So a process also which creates another process is called as a parent process. So my window, whenever I open, it will directly open a new screensaver for me. So it called as a parent to my screensaver. And the one that being created called as a child. So it's easy for you to remember that because it is a normal term using a family like parents and child. And then every new process can be create another process. Of course, this one is you can link it all together. Then another one is on your process termination. Of course, process could be terminated whenever program is terminated. This is just a makes sense. Process creation, what happened inside also in process creation, basically it's just a similar the operation involved, and then why, reason for the creation. Maybe because you already said it, or maybe because after you finish certain application, maybe you reach on a level, then it's automatically open new. So it's depend on what reason for you to create a new process. And on the process termination also, you have the reason. Of course, any kind of thing happening inside this world, there will be a reason. Similar also with the process, whether you want to terminate or you want to create, you need to have a reason. And then operations on process terminations also you need to know. Then context switching, which is you want to switch to another. Let I give you example, like changing in information when CPU is switched from one process to another. And then you store the current process state for the process that leave the CPU in PCB, and load the state of process that is being allocated for your CPU. So this is the example of context switching, but there is another also. There's another which is on time taken for context switching is considered a system overhead. So you need to know also on the overhead side. I don't know whether you already learn it in your other subject, but overhead is a normal term in networking. So whenever you are dealing with your networking side, then you are dealing also with the term of overhead. I think overhead is happen anyway. So next, on your speed also, normally it's going to be like a few milliseconds and etc. So this one is just to show you the context of switching between two processes. What happened in between? You can have a different kind of switching flow, etc. But this one is just an example. If let's say you have two process happening, and what happened in between is the switching part from this process PO with the process PI. You can have a link it together, which is called as a context switching. So this is a context switching. You might have similar diagram like this if you have a similar process, but you can have also a different kind. But the basic one, you need to know that you have the educations first in the first parenting process, and then this is one is your child process. So you have the education on your parenting, which is what it will start first, and then it will link to your system, whether you want to interrupt or wait or whatever set here, and then until you have doing something, and you will trigger, which is contact on switching with another process. So, and it will vice versa. So when to switch a process, so it's depend on you, also depend on the process itself, application itself. So when you have to switch, there is also a reason, depend on, let's say, a clock interrupt or I input output interrupt, maybe also in the memory faults and then trap, and also sometimes you have the supervisor code. It's depend on what happened. We are dealing with many things happen in our PC. Sometimes it's suddenly corrupt, sometimes suddenly stop. So this is all the reason on switching one program to another process, to another. And last thing on your operating process, which is there is a concurrent process, and also you will look into your advantages on the concurrent education. So concurrent process, you have two, which is independent and cooperating process. While over here you're going to look into the advantages, of course, and the concurrent education requires. So there is a difference on concurrent process and also concurrent education requires. So you can go through and try to read all of these, make it remember for the terms, and make it understand for the knowledge and technical part. Is it okay? So any question you can just asking me. Also when I am learning programming, of course, there is a lot of information just new for me, and I feel like bored because I need to learn on theory, and all of this is just a theory. So whatever it is, we already finished our chapter, and we need to jump to MPI. So the MPI video also I already provided in the YouTube, so please look into it, try to run the MPI also. I also provide the step by step how you're going to run, and let's say there is an error, how you're going to deal with it. And there is also a new command on how to execute the file, which is using MPI. Is it okay? So thank you for watching and have a good day. Bye bye.